All right. So, hello, I'm Michael, and I also have my colleague Robert joining here today from Bosch. I need to start with the obvious statement, and that is that we're not. Everyone here has so far talked about kernel space quite a bit, and I'm mostly going to talk about user space. And I'm sorry. Uh, Exactly. So well, we don't have any pitchforks, so quite happy about that yet. All right, good. I know what to expect. Me and my colleagues have worked on well, a bike computer, that one, and we also brought a bike. It's right here, and as soon as you have the opportunity, you should try this. Come down here and try it out, or in the breaks, try it out. Um, and I'm mostly going to talk about the software and the problems we had building this device. Um, and I also couldn't choose which of these two pictures I was going to have as the first picture, so I picked both of them. It was very hard for me. I liked both of them. Anyway, just to give you an idea about how the bike works. So this is an electric bike, of course. It has a drive unit, a battery. We have an ABS, and for me that was a shock the first time. Wow, we have an ABS on the bike. But apparently, if you want to drive downhill, it's very good to have an ABS on the bike because you're gonna survive. And that might be beneficial. And this is all connected using in this generation. This is generation 2. Then this is connected using CAN, which is then we have automotive people here. So CAN bus is, I'm assuming, quite a big deal for quite a few of you. We are also using CAN bus, and it's awesome because it's CAN bus. Some before we go into the software, I feel like we need to at least mention some of the hardware of this. This is an IMX6 1 gigahertz dual core device. It has a 1 gigabyte RAM, 3.2-inch display, 8 gig flash, connectivity is CAN BLE. We connect to smartphone, and we have Wi-Fi and GNSS and pressure. And also this remote here is running electrical signals, and then we're doing an IR protocol on top of that, which is an awesome design that I feel like we should definitely. No, that was. I have no idea why we picked that. Um, okay, and then we go into software, and now we're going to start talking about a quite major component that we are using in this device. So I'm assuming most people have heard of Chromium. We had an entire Chromium. Where's the Chromium guy? Is he still here? Yeah, exactly. All right. We're using Chromium. And of course, we couldn't really use Chromium in that way, but there's another open source project called Chromium Embedded Framework, and what that does is it scales away a whole bunch of stuff that we don't need from Chromium, and then it wraps Chromium, well, Blink engine and V8 engine um, into a stable API we can use to launch a web browser and launch, let's call it Chromium tabs. Um, I love it that we have a Chromium guy here because he's going to correct me. But um, anyway, Chromium Embedded Framework is heavily used by us. We take this API and we use that quite a bit. Um, and if we start now, we were responsible for the entire software stack from well, in our case, U-boot and all the way up to the UI layer, and we worked with every bit of it. So we worked with a whole bunch of open source components, and we worked with the UI. And on the UI layer, we decided we were going to run HTML over there, which is why we selected Chromium. Um, and those are basically HTML single page applications. And if we go to application management, that's basically our C++ component that uses the Chromium embedded framework APIs to launch, let's call it Chromium tabs. So each tab gets an HTML single page application in it. Confused? Yes. Awesome. I have a picture on the next slide that might help. Below that, we have, of course, all the usual stuff that you need. We need the HTML apps need somehow to get hold of Bluetooth. So we have Bluetooth services. We need Wi-Fi. We have a CAN, of course. We need that. We are on a CAN network. We do need to talk to CAN, and a few other Bosch services. That's sort of our middleware then. And then, of course, we have the entire open source community of basically 250-ish open source components that we're using in this project. And that's, well, NSM, dbus, obviously, Dash, different JSON parsers, and everything else you need in the root file system to actually make this thing work. Systemd, yeah, and more. And we, of course, also have a build system, which is Yocto. And we continue on with the HTML topic. So here's our UI. It's fairly special. We have a background, and the background is an HTML application. We have stuff on top of that background, see-through HTML apps. So essentially each screen here is separate. Well, every one of them is a HTML standalone app. So we're taking one HTML app, we're making it partially see-through, and we're rendering it on top of another HTML app. And now somebody in the audience might come and start thinking, but why are you doing this? Isn't it complicated? Couldn't you have done it in another way? Well, I'm sure that all of you, of course, work in projects where requirements never change. Obviously, you have the requirements based from the beginning, and you know exactly what you're going to do, and nothing ever changes throughout the project life cycle. And that's not the case with us. Some things changed. So we had requirements that motivated this kind of a design, and one day we did not have them anymore. So stuff happens. Either way, this is what we have now. We have partially see-through apps, web apps that we render on top of each other, and those are all essentially Chromium embedded framework. Let's call it tab. I really like that. So we have a bunch of Chromium tabs up and running. That's cool. Obviously, running a whole bunch of Chromium tabs, I mean, they are sandboxed. They require memory. They also like a lot of memory because it's a sandbox. It's supposed to protect against a whole bunch of stuff. So, all right, we need to consider memory. But it's good. We have 1 gigabyte of memory. Roughly 250 for the apps. It's a lot, but all right, we're good. Continuous memory and GPU has 128. User space for other user space native stuff, 150. Okay, we're roughly good. And of course, then navigation is a key feature of this device. So we need a whole bunch of memory for that. So Navigation is one of those cases where, well, the more memory you give it, the faster route calculations will basically go. So if you could give it a gigabyte, you would give it a gigabyte, or 2 gigabytes, or 10 gigabytes. You can just basically throw gigabytes at it, and it would be awesome. Unfortunately, we are on memory budget, so we go ahead and just give it the 250. Now, this is a peak picture. So this means some poor tester in my team has gone out and enabled everything he can enable. He's also been out biking for hours, and he is questioning his life choices. But either way, it's a peak picture. We're good. We got this. We have about 10 Chromium instances running, all of those plus a few hidden ones. But we're good. Of course, we're not good. We're bad. Well, the first thing that well, not maybe the first thing, but one thing that did happen was, so when we're out biking, we have of course security requirements. We're encrypting into continuous memory from the file system, changing files and putting it down again. And when we're doing that, and again, peak scenario, the user has been out for a while. It's not great. Then we don't have any more continuous memory. It's out. We're out of it for a peak second. And the kernel is very helpful during that peak second. It decides that, all right, I'm going to remount your file system now. It's read-only. And nobody detects this. Nothing happens. It's just awesome. It's done. And except later. So the user isn't detecting it then, but he's detecting it later when it's trying to upload this activity data to the backend. And the backend says, what activity data? I didn't find anything. You gave me nothing. Because the file system is read-only, so nothing gets stored. Okay, problem one. And then, of course, we're using an open source EtnaBib driver here. Apparently, that thing also needs memory. It's a shared memory type of video graphics system. You need to give it more memory. So and that was also very helpful. It just goes black screen, and then nothing is awesome with that anymore. So we gave it more. We gave them more. So we tested a whole bunch. Our testers are still alive, and we gave them more. So we're good. We came a bit higher now in the peak usage. That's a bit problematic, but we're still good. We're not good. We added a whole bunch of more features, and of course they're all also Chromium frames, all of them. So that occupies a whole bunch of. Now we have too many instances. We're above the limit. All right. But well, wait, we can fix it. We can do something with this. We can unload stuff. I mean, everything doesn't need to be loaded in memory once. We just need to have it loaded when it needs to be loaded. So all right, we fix that, and we can actually also work with the memory. I mean, we don't need to. I mean, I suppose that we as developers sometimes need to care about memory. I guess. So we reduced the memory. We fought with that for a lot, and of course we dynamically unload and reload. So we're good. We're good. We're not good. Of course, we had customization options. The user is allowed to go in and basically define what he has on his screen. And we have like 50 customization options. So he can add a whole bunch of more. We decided to cap it at some point. Now, when I argued for capping within the limits of the memory budget. But it turns out product management wants to cap it at some type of user-friendly limit. Those two things were not the same thing. All right. Bad. okay, how are we going to save? We have only a gigabyte. We don't have the 1200. Now we're in a bad situation again. All right, what are we going to do next? Uh, but I know we have SedRAM. We can okay, and I hear that the SedRAM guy is someone in Lund. Is he here? He should have been here now. So well, we found SedRAM, and SedRAM is awesome because now we pretend we have 2 gigabytes. Of course we don't, and of course we didn't actually stress it to become that much. But all right, SedRAM allows us to compress memory into memory, essentially. So it gives us a much higher buffer. And now we're good. We ship it out. Okay. So obviously we knew that we could not deal with the memory constraints. We obviously knew that. I am kidding here. We knew, of course, the problems would arise. We had calculated the budget. We had realized how much we could afford. Um, but SedRAM was very helpful for us. That indeed allowed us to go over the budget again during peak situations, and it allowed us to launch a much more Chromium instances than would probably be beneficial on a 1 gigabyte embedded device that is absolutely not built for having a whole bunch of Chromium windows on it. Um, I think we might be unique in this particular setup. That anyway, this is an working product now. People are, as far as the feedback goes, we're fairly happy with this. And while when you have a look at this later, I want you to look at it with the eyes that we are running a whole bunch of Chromium processes on this, and with the eyes, all right, how's the performance? And I'm actually fairly proud of us managing to get this thing out. So feel free to have a look. Continuing, we are I'm not sure if we have time for everything here. We're gonna yeah, okay. We do this part as well. So obviously boot performance matters. And again, we're launching 24 Chromium windows, so it does take time. But also it is a CAN network. The bike will, in this generation 2 bikes, they will not function without the display being ready and launching and talking to the rest of the bike. The bike enables with the display. So we have to be fairly fast in launching the CAD network. We had a special kernel driver for that, and we have so it's one of the first things that gets launched. So we do not. The usual thing with CAN is that you have like your own special microcontroller in a free RTOS environment, and or an RTOS environment. But we actually have it on just Linux, and it's started a bit earlier, but the higher level service starts about 2 seconds in. We are using systemd, of course, for the entire boot procedure. We are, of course, grouping the targets. I assume, or I'm guessing everybody knows what systemd is because you're the Linux community and you know everything. That's how that works. We can wait CPU usage during boot, so only the things that needs to have CPU in the right time frame gets it. And then when we come to the UI, then it becomes fairly special again. So we have like the main server up there, and that's one process, and it launches all the renderers or all the Chromium tabs. The Chromium tabs are all unique in processes. They have one process per render essentially, so that's fine. It's just that you need to actually launch quite a few of them. And then we couldn't use systemd anymore because systemd allows grouping on sort of the main process, but I'm doing a whole bunch of child processes. So instead of using systemd, we used cgroup this time. So say that, all right, now I'm launching this UI component. That's the main UI component. This one gets 100%. You get everything. And of course, everything that's not visible to the user. All right, you still get something. The main tab get 90%. The others get 10. So you load in the background. It just exists there. But then we used cgroups to do that. So that was another sort of fine feature for the open source community. And now I think we're going to skip this because we're needing to switch to... Yes, we're going to skip this. Because we're running out of time, or at least that's... Yeah, okay. No, but I also have we have more slides, and Robert is going to also soon here talk about another part of it. I'm just going to mention two things here. The open source community is great. We could not have built this. Obviously, we were using Chromium. We're using 250 other components. By the way, Chromium is just as large as all the other components combined, if not a lot larger. So we have a whole bunch of components, and we just picked the 250 we want. But nobody has actually qualified those 250. And those 250, these are our 250. Nobody has qualified that they work together in our product. Nobody's verified that the revisions we're using of all of these fancy components will work together in our constellation. That was actually a big deal of our project. So we are special, and so is everybody else who does an embedded product, I'm assuming. And it's hard staying up to date. You have to keep updating all the time. You have to keep updating because of mostly the security requirement, staying up to date. Because if you don't keep updating, then you get one of your colleagues here coming and yelling at you because you're not updating. And it's open source, you want to keep updating. The problem is you end up in with problems every time you update. So every time you update, you're going to run into something like Bash deciding that, all right, now I'm GPL3. Awesome. That's blacklisted for us. Okay, now we need to redo something. Or when somebody integrates something bad in our Etna driver, that wasn't detected by the community, and we have no idea why the screen is black this time. Because that's what you see. All right, the screen is black this time. Yeah, and we have more problems like that. So I think the main message for us was that it's actually fairly hard to work with. The open source community is great. We want to be there. We love it. It's still a lot of work, even if it is open source. It still requires resources. It still becomes a somewhat large chunk of the project. Yeah, and I think that was the message I want to be on that one. And now I'm heading over to my dear colleague.
Thank you, Mikael. I take it video. So I will be talking about the screen on the device, and you can check if that exists. And there are licenses in it. There is a story behind this, but if I just want to summarize what I will be saying here, of course, we want to be a good OSS citizen. On the other hand, we only want to fight with the open source components that are actually on the device. And that's not always so easy to tell what is actually on the shipping device. So I will just give you the brief story here. I think I have 7 minutes because we started 49. So yeah, if you look at our OSS disclosure and published source archives, you will find them on the web at this page. So I'm starting this from the user point. So we will work ourselves backwards, and there will be a Linux point at the end. So how do you get stuff here? Have you thought a big company, who manages the web in a big company? Well, it's usually marketing. And I'm quite far from that department in a 400,000 people company. So first part is find who manages this page. And then you realize they have to publish the stuff. But with Chromium and the stuff that Mikael has mentioned, this is more than, each of these is more than 2 gigabytes of data. So you can't ship them a big file, you need to split them. That's why we have download 1, 2, 3, and 4. That's the source code, and here are the licenses. That's much smaller. But once you get hold of these guys, they are wonderful to work with. So second time is no problem, but the first time was quite interesting. Okay, so this doesn't remind you of what I showed you before. But as Mikael mentioned, requirements change. And first we had acceptance to actually do a barcode which you scan with a mobile phone, and then you get the previous page that you saw on the web. But not on this device. Because this device has Chromium, but it's not a web browser. I mean, we don't use it for that. It's a use case, but we don't use that. So we had this, and then requirements changed. Because when it was shipped and people started using it, many people inside realized, wow, this has such a big screen. It really should fit a full license disclosure, like you have in your Android phone, for example. By the way, which one is terrible? It's just a boatload of files and linking to licenses. You see. So I think our is just as good. Yeah. So the story behind this, then, we changed the requirement to go from this to this. And what does that mean? Well, it's just a few ruddy files, isn't it? But the thing is that to get the approved files that are reviewed by everyone involved, because we want to be a good OSS citizen, what can you get? You can get Word, or you can get PDF. And you will note there are external vendors also. That's PDF. In the worst case, it's even PDF with just images in it. And rendering this in a sensible way in a small screen is quite difficult because you have these tabs and indentations and stuff, which suddenly eats up your valuable screen estate. So we had Word and PDF, and we tried rendering them, and it was useless. So we had to go back. So request, can we have plain text files? And then we can actually regenerate this using the beauty of Markdown. Because if you can get to Markdown, you can get anywhere rendering-wise for the purposes we have with the text here. Not talking about tables and other stuff that Markdown is bad at. But anyway, so we had to redo this using Markdown, and it was a great story to realize that we have Chromium, but we can't render because the device is so cramped. So we really need to take into account the layout. Yep, I will speed on. I have 3 more minutes. So the means we had was up here, but these are the real goals. We want to publish documents. We also want to have some continuity that our CI system can actually keep track of breaches and any other patches we have, so just the technical debt. And then, of course, we had the initial intention of actually generating the document you saw from the CI system, which was, we tried a lot of ways, but we couldn't reach it because there was always stuff lacking. We didn't get the full set of licenses. So still a lot of automation, but still a lot of manual work because you still had to ship stuff for manual product scanning. And then, of course, the review and approval process for this is also manual. And it involves product owners and legal people. So what the summary of this is, if you do the review process naively, you just realize, well, I just shove it in there and they will approve it for me. But that can take 2 weeks, 3 weeks, 4 weeks. It could take forever. So the trick here is once you have stuff that looks like it's somewhat decent, ship it in there and book them proactively for reviewing. Because if the reviewers of the actual open source, the legal people and the product owners, if they are involved early, you can speed it up by a factor of 10, I would say. Because then they feel invested in the process, they find errors and you fix them. And then they feel they have actually impacted your work. And the quality goes up also, because we still want to be a good OSS citizen. That's why we're using open source. Final slides then. So this is just a description. It shows the bit-baked stuff, how it generates the dependencies and what goes in. This we didn't get to work fully, but we almost got there. So my final message here is, this is just a summary slide again. This is what we should have done if it had been available in time. And I really recommend you look into this. The double open project that actually helps you solve the problem. What is actually shipping in the software and has the licenses that are approved. The double open project actually does this correctly with Yocto. It actually inspects the build chain, it inserts itself as BB files, and then it actually outputs what files are actually in the build. And from that, it can generate the proper licensing. And the fun thing is, this project is actually implemented by an actual lawyer. Well, one of the lawyers in this firm, but he's really technical. He helped me debug the problems I had with Yocto when I prototyped this in the very far end of our project, which is a bit too late to get it shipping. But if I had done it today, this is the way to go. Yep. So be a good citizen and know what's on your product. That's my message here. Questions? Mikael, to me? Yeah?
If I were to buy the product, would I have a chance to think already?
Sorry, what you have to?
Would I be able to think already, like having a UART connected or something to see exactly what's going
We
on?
have a long list of security requirements.
Security requirements, yeah.
If you would succeed with that, I would want to know about it.
Yeah, there are a lot of requirements to
This is
have.
basically the problem with products that are using Linux.
Yeah,
But for guys like me, if I'm not able to see what's inside,
yeah,
then it fits the purpose, right?
yeah. It's a compromise. Yeah,
It's also smartphone manufacturers were also like that in the beginning. Nowadays, I think from smartphones we can get the smartphones unlocked and we can do
Yeah.
stuff with it.
but yeah, we can bring that question home.
It's a bit new territory for me.
Yeah, it's new
It would
territory.
be nice. I think
Yeah, it's neutral. Yeah,
Linus is working on some project for scuba diving, right? And that one has provides you access to Linux, and you can do stuff from there. But like most of other products are not able to
yeah.
provide that. So
I'm fairly sure you are aware that this is not a developer choice usually.
But you can also say that the scuba thing from Linux, they started out by reverse engineering everything. So I think now people the manufacturers are more nice about this, but
Yeah.
in the beginning they reversed engineer everything. Literally, like if I put this down 1 meter in water, how will the value change?
but think about it. This would help you guys, because if you provide everything.
It depends if you're on the 25th tab.
Yeah, don't go
It's pretty
25.
much shipping with the knowledge they have. So
Yeah.
This is mostly a topic where we have very strong security, and it's not a developer choice. This is not driven by development and that.
Yeah, it's a little bit follow-up question to that one. It's an important question. Where is the speed and acceleration limit set?
been poking around there, so it's a subsystem that is totally different from the one we do.
At least do not look online.
I think we will need, I think we manage more questions in the end, but you have more on this similar topics, right? On this, you know, this is,
We have more on other topics.
Yeah,
that we're
yeah.
touching topics.
In the same.
Thanks for your time.
Yes.